Okay, dear students, welcome to Design and Analysis of Algorithms. So we are making some discussions yesterday related to time and space trade-off. Okay, so under this we have considered few problems related to string matching. So under this we have made some discussions using brute force string matching mechanism. And in input enhancement technique, or what we can say time and space trade-off, so we are going to give much more focus on the processing of the input. What we can also call this as a pre-processing. Okay, so pre-processing is a technique where we are going to enhance the quality of the input before we are going to process it. So under this, we have some of the standard string matching mechanisms like the Heuristics string matching mechanism, and of course we have Boyer-Mourley algorithm. Okay, so yesterday we have made some discussions on Heuristics string matching. So today we are going to continue with the Boyer-Mourley algorithm. So once again, this is a technique in order to search the given a pattern in a given text by using two types of mechanisms. So how this can be achieved and all those things we are going to make some discussions now. So I'm going to share the PPT, dear students. Kindly go through it. So whether the PPT is visible for you?
Yes, sir.
Okay. So input enhancement using Boyer-Mourley algorithm. So how this algorithm will work, we will discuss. Okay. So once again, it was it was last updated in the 2019. So it's a technique of pattern searching. So pattern is a substring, and this substring needs to be searched in a text. Okay. So in an important problems in computer science, it is going to play a very important role. So we do search for string in Notepad. I think people use Word, MS Word, Notepad, WordPad, isn't it? So if suppose if there is a huge Word file, and if you want to search a particular pattern in that, you will go for Control F. Yes or no? Control F ಮಾಡ್ತಿರತಾನೆ find and replace in
Yes,
Word documents. Yes or no?
yes, sir.
Fine. Okay. So in those editors like notepads, or it may be the Word documents. So these type of algorithms will be used in order to search a given pattern in a huge file or a text. Okay.
ಸರ್
Ready?
ಸರ್ ವೇಟ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅಲೋ ಮಾಡಿ ಸರ್.
Okay. Fine. Anybody else? Okay. If anybody is waiting in for me, I will add that. Fine. So under this we have the standard searching algorithms like among one of them is the Boyer-Mourley algorithm. Okay. So it's one of a typical problem, searching problem. The statement contains the following. So you will be given a text. So the text will be given. So the variable is txt. So txt is a variable, and this will be considered as a text, and 0 to n minus 1. So this is the array of characters because it's a string. So the indexing starts from 0 up to n minus 1. So n will be the length of the text. And under this we have a pattern. It is represented by the variable pat, and it is going to index it by 0 to m minus 1. It indicates that the pattern is of size m. Okay, so pattern is a substring, and this pattern needs to be searched in the text. Next, write a function search. So search is a function. So pattern will be passed as an argument. The return type is character array, and txt will be also passed as an argument, and once again the return type is character. That prints all occurrences of pattern. So what it is going to do, it is going to print all occurrences. Occurrences means the findings. How many times the pattern is present in the given text. 1 time, 2 times, okay, and also the position. So you may assume that always n is greater than m. N means the length of the text, and it is text is always higher than pattern. So this is the prerequisite of Boyer-Murray algorithm. So now we'll take some examples. Okay. So we have an input here. Input is a text. It's a text character array. So it tells that this is a test text. So this is a test text. So this is the text, input text, and the pattern array is test only. So we have to search this pattern in the given text. Okay. Next, we have output here. Okay. So the output is we have to pattern is found at the index 10. So how this 10 will come? So this T will be compared with T. Okay, so there is a match. Next, E will be compared with H, so there is a mismatch. Once again, T will be compared with H, means the pattern will be moved one position right. So there is a mismatch. Once again, there is a mismatch. There is a mismatch. Okay, so and this is a space. Once again, a mismatch, and I mismatch. S is a mismatch. A. Then we have a match here. T will be matched with the T. E will be matched with E, S will be matched with S, and T will be matched with T. So if you count the positions, suppose if this is a 1, this is a 2, this is 3, this is 4, and this is 5, 6, 7, 8, 9, and 10. Okay, so this will be the position. So that is why it will be given as a text. But sometimes what happens in Boyer-Murray algorithm, we are going to search from the right side instead of left side, which is what we are going to do in case of heuristic. In particularly in brute force mechanism, we are going to perform from left to right. But in case of Boyer-Murray algorithm, so this is quite contradictory. We are going to search from the right side of it. Even though if you search from the right side, the position, the 10 will be the same. So similarly, we will take another text, a second example. So this is a text, and these are the pattern we have searched, and output pattern is found at index 0. Suppose if you consider this as a 0 position, 1, 2, 3, 4, 5, 6, 7, like this. Then A will be compared with A. A will be compared with, if you start from left side, but actually it starts from right side, from here onwards, A, B, A. So there is a match here only. So it is present at, he is telling that 12, 12. If you take this as the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this A and this A will be matched. So this second A and A will be matched B, A. So B, A. So 12, 12 will be the position. Similarly, 9 is also present here. See A, B, A. So this is the 9th position, and 0. So this is the 0th position. So in all the positions, we are going to return the pattern with respect to its position. So similarly, there is another example here. We can same thing is discussed here also. So pattern is found at 0. This is 0. This is a print mistake. So this is 0, 9, and 12. So how this will be compared? So if you consider the green letters, so the green letters is a text, and the blue letters is a pattern. So there is a match here. There is a match here. So pattern match at 0. So this is 0. This is 0. And this is 9, and this is 12. So how this Boyer-Murray algorithm will work? Okay. So in this post, we will discuss the Boyer-Murray algorithm, searching algorithm, like KMP algorithm. Okay, KMP I have explained in my previous class, and also this type of algorithms are used in finite automata. Okay, in particularly for heuristic search mechanisms. So and this Boyer-Murray algorithm also it pre-process the pattern. So what it is going to do? It is going to pre-process the pattern. Pattern means the substring what we are going to search. And this Boyer-Murray algorithm is a combination of two approaches. So commonly two types of techniques or methodologies employed in this Boyer-Murray algorithm. So the first one is a bad character heuristic, and second one is a good suffix heuristic. Heuristic is the random searching mechanism. It is purely based on the artificial intelligence or to some extent It is based on the finite automata. So first one we will take the first one, that is the bad character heuristic. So, the Boyers-Murray algorithm, it preprocesses the pattern and creates different arrays for two types of tables. One is for the bad character and another one for good suffix heuristic. So two types of tables will be created. First table for bad character heuristic and second table for good suffix heuristics. Okay. So at every step, it slides the pattern by maximum of slides suggested by the heuristic. So what it is going to do, as per the logic given by the, either it may be a bad character or it may be good suffix. So the entire pattern will be shifted. Okay, so it uses best of the two types of mechanisms. Either it may be, suppose if the bad character contains less number of shifts, it will go for bad character heuristic. On the other hand, suppose if good suffix heuristic contains less number of shifts, then it will go for good suffix technique, because basically in string matching operations, the comparison will be considered as a basic operation. So, and our objective, we have to always reduce the number of comparisons so that we can avoid the number of basic operation execution. Because the basic operation execution is, it's going to play a significant role in the case of order of growth. So, the order of growth of any algorithm is directly proportional to the basic operations. Number of times the basic operation is executed. And in our case, in string matching mechanisms, so comparison will be the basic operation, and our objective is always towards, in order to reduce the number of basic operations. Okay. So in this case, it is the two best mechanisms. Which one is the best means less number of comparisons, it will switch over into that particular technique. So unlike the previous pattern searching algorithm, so Boyers-Murray algorithm starts matching from last character of the pattern. Remember, it is going to make the comparison from the last character of the pattern, not the text pattern. Okay. So in this post, we will discuss some of the bad character heuristics and as well as good suffix. Both the techniques we are going to discuss now. The first one, that is bad character heuristic, first mechanism. So how this will work? So the idea of the bad character heuristics is extremely simple, very simple. So however, the character of the text which does not match with the current character of the pattern is called as a bad character. So what is a bad character? It's nothing but the character of the text which does not match with the current character of the pattern. Current character of the pattern always from the extreme right. Extreme right character will be taken as a current character of the pattern. That will be matched with respect to the text character present in the text. Suppose if there is a match, it's a match. Suppose if it is not a match, we will treat this as a bad character. So upon mismatch, suppose if there is a mismatch, what we are going to do? We shift the pattern. We shift the pattern until two cases here. First case is mismatch becomes a match, or else pattern P move past the mismatched character. So under bad character heuristic, so we are going to follow two cases. The first one is if there is a mismatch, okay, we have to make a match. Means that we have to move the pattern so that there may be a match. The second one is move the entire pattern P to the last position of the mismatched character. So if I keep on telling on this theory concept, it is a bit difficult. So that is why I will go to the example. So now you see this case one. So how this case one will work. So under this case one, that is case one ಏನಪ್ಪಾ ಅಂದ್ರೆ the mismatch becomes a match. So mismatch becomes a match. How this will work? Let us find out. So we will look up the position of the last occurrence of the mismatching character. So we have here a text. So G, C, A, T, G, double C, T, A, T, G, T, G, A, C, C is a text. And T, A, T, G, T, G is a pattern. And we have to search this pattern under this text. And each position of the text will be numbered. 0 is the position of G, 1 is the position of C, 2 is the position of A, 3 is the position of A, 4 is the position of T, like keep on, okay? Till 16 will be the position of C. So now how this mismatch become match will work, let us find out, okay? So what we are going to do here, so first we will make the identify the last character of the pattern. Which is the last character of the pattern here? Come on. Which is the last character of the pattern here? Dear students, are you there?
D.
Where I am rolling over my mouse. Last character. This is pattern. This is
G.
a
G.
G. G will be the last character of the pattern, and this will be compared with the text. Okay, so there is a match, no problem. Now we will go to the second character. We will scan from right to left. So we will go to the second character from right to the left of the pattern, and once again we will compare this character with the character aligned with respect to the text. So whether there is a match,
Yes, sir.
there is a match. So once again, if there is a match, once again we will scan towards left side of the pattern so that we can encounter the character G. And this G will be aligned with the character A in the text. Whether there is a match,
No, sir.
no. So there is a mismatch. So whenever a mismatch occurs, what we have to do, we have to search this character A, occurrence of A in the pattern. Okay, in the pattern. So where it is present? It is present in the which position?
First position.
First position. The character A, which is present in the text, is also present in the pattern at the position A, at the position 1, at the position 1. So what we have to, we have to shift the pattern such that it get aligned to the mismatching character in the text. Okay, so this A will be, this A, that is the position 1, it has to be shifted to the position 3, because in position 3 we have the character A in the text. So that is why this A will be shifted to here. Means if A is going to be shifted here, T will be shifted here, this T will be shifted here, like that. So here you can see here. So this A will be shifted here. We can see the A will be aligned with A. Then T will be aligned with place it here. Next, uh, this T will be placed here. Okay. Then then G will be placed here, and T will be placed here, and G. So whether there is a match now, of course, there is a match here. Of course, there is a match here, but there is no match. So once again, we have to do the same thing. We have to compare G and C. So there is a mismatch. Once again, what we have to do now? We have to find out the occurrence of C. The occurrence of C here, but C is not at all present here. Okay. So once again, we have to go to the second. That is, the T will be compared with the C. Once again, there is a mismatch. So once again, the C is not present, but there is a match in G. There is a match in G. There is a match with respect to A. But once again, T is not equal to A. So once again, we have to find out this A. So A is present in the third position. So it is present in the third position. So that is why. That is why. So what we have to do, so we have to move this. We have to move this A again with respect to the A. So this process will continue. This process will continue until and unless all the mismatch becomes match. Okay. So you go through once again I am going to explain this. So nodi illi enagta ide, we have a pattern and this is a text. So the pattern, the last character, the extreme right character of the pattern will be matched with the character which is aligned with respect to the text. So there is a match, no problem. So there is a second character of the pattern and as well as the character aligned in the text. Once again there is a match, no problem. But when you encounter the character G in the pattern and it will be matched with the character A aligned in the text, so there is a mismatch. So the mismatch occurs because of the occurrence of A. And now what we have to do now, whenever there is a mismatch occur, so find out the occurrence of this A in the pattern. So it is present at the position 1. Okay. So it is present at the position 1. So what we have to do, this A has to be placed here. Means the entire pattern has to be shifted at such a way that A will be aligned with 3. Okay. So that is why A will be aligned at the position with. You can see here. Okay, and this process will continue. Okay, so that is what the explanation has been given here. So in the above example, we got a mismatch at the position 3. Here, our mismatching character is A, and this A has to be searched for in the pattern. It is present here. Okay, and we got A at the position 1. So this is the position, and in pattern, so that is blue. Okay. So, and in this is the last occurrence of it because A is last present here because after A we have T here. Okay. So now we will shift the pattern 2 times so that A in pattern get aligned with A. So we have to shift 2 position 1, 2. So now A will be aligned with A. Now once again we have to compare the other characters. If there is a mismatch, the above process is repeated. So this is called as mismatch becomes match. And now the second case, that is pattern move past the mismatch character. So what is second case? Pattern move past the mismatch character. So how this will work? Let us find out. So any doubts here in case 1?
No, sir.
Okay. So in case 2, how this will work? Let us find out. So once again, we will look up the position of the last occurrence of the mismatching character in the pattern. Okay, ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಅಂತಂದ್ರೆ ಪ್ಯಾಟರ್ನ್ ಇದೆ ನೋಡಿ, this is a pattern, this is a text. So ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we will try to find out the last occurrence of mismatching character. ಎಲ್ಲಿ ನಮಗೆ mismatch ಆಗ್ತಾ ಇದೆ ಆ ಲಾಸ್ಟ್ ಕ್ಯಾರೆಕ್ಟರ್ ಯಾವುದು ಅದನ್ನ ಕಂಡುಹಿಡಿಯಬೇಕು. Then if character does not exist, we will shift the pattern past the mismatching character. We will just shift the entire pattern. So how this will work? Let us find out. Okay. Okay. Nodi illi here we have a mismatch at position 7. Nodi first ನಾವು G ಜೊತೆಗೆ C ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ, ಅಲ್ಲೇ mismatch ಆಗ್ತದೆ. First character ಏನಾಗ್ತಾ ಇದೆ? Mismatch ಆಗ್ತಾ ಇದೆ. So the mismatching character C does not exist in the pattern before 7. So now this mismatch occurs because of occurrence of C in the text. Now what we have to do, you have to search this C in the pattern. But the thing is, C is not at all present in the pattern. C is not at all present in the pattern. So we have to first C will be compared here, C will be compared here, C will be compared, C will be try to locate the C. Once again try to locate the C, try to locate the C. So this is the last position. Okay. So what happens? So we will shift the pattern past to the position 7. Okay. Since 7 is the position and C is not at all present in the pattern, now ಏನು ಮಾಡ್ತೀವಿ ಈ 7 ಬಿಟ್ಟು next position ಯಾವುದು? What is the next position after 7? 8 ಅಂದ್ರೆ ಈ ಟಿ ನ ನಾವು 8 ಗೆ ಅಲೈನ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಅಂದ್ರೆ ಇಷ್ಟು ಪ್ಯಾಟರ್ನ್ ಕೂಡ ಈ ಪ್ಯಾಟರ್ನ್ ಫುಲ್ ಜಂಪ್ ಆಗತ್ತೆ. ಎಲ್ಲಿಗೆ ಅಲೈನ್ ಆಗತ್ತೆ ಅಂದ್ರೆ 8 ಗೆ ಬಂದು ಡಿ ಅಲೈನ್ ಆಗುತ್ತೆ, 9 ಗೆ ಬಂದ್ಬಿಟ್ಟು ಎ ಅಲೈನ್ ಆಗ್ತಾ ಇದೆ. ಓಕೆ, ಅಂದ್ರೆ ಏನಾಗ್ತಾ ಇದೆ, ನಾವು ಇವಾಗ ಒನ್ಸ್ ಅಗೇನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನೋಡಿ. ಸೊ ಈಗ ಒಂದು ನಮಗೆ ಪ್ಯಾಟ್ರನ್ ಇದೆ ಟಿ ಎ ಟಿ ಜಿ ಟಿ ಜಿ ಅಂತ. ಸೊ ಅಂಡ್ ದಿಸ್ ಇಸ್ ಎ ಒನ್ಸ್ ಅಗೇನ್ ಎ ಸ್ಟ್ರಿಂಗ್, ಐ ಮೀನ್ ದಿಸ್ ಇಸ್ ಎ ಟೆಕ್ಸ್ಟ್. ಸೊ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇದೇ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲಿ ಏನು 7th ಪೊಸಿಷನ್ ನಾವು ನಿಂತ್ಕೊಂಡಿದ್ವಲ್ಲ, ಸೊ ವಿ ಆರ್ ಕಂಟಿನ್ಯೂಯಿಂಗ್ ಫ್ರಮ್ ದಟ್ ಪೊಸಿಷನ್ ಓನ್ಲಿ. ಓಕೆ, ಸೊ ಈಗ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು, ಸೊ ಸಿ ಜೊತೆಗೆ ಜಿ ನ ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ, ವೆದರ್ ದರ್ ಇಸ್ ಎ ಮ್ಯಾಚ್.
No, sir.
ನೋ ಮ್ಯಾಚ್. ಸೊ ನಾವು ನೋ ಮ್ಯಾಚ್ ಅಂದಾಗ ಮಿಸ್ ಮ್ಯಾಚ್ ಯಾಕೆ ಆಗ್ತಾ ಇದೆ? ಅಕರೆನ್ಸ್ ಆಫ್, because of the occurrence of ಹೇಳಿ. ಸೊ ಇಲ್ಲಿ ಜಿ ಇದೆ, ಟೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಏನಿದೆ? ಸಿ ಇದೆ ಅಲ್ವಾ? ಸೊ mismatch is occurring because C is present in the text. Now if there is a mismatch, ನಾವೇನ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, we have to search this C in the pattern. But whether C is present in the pattern?
No, sir.
No. So ನಾವೇನ್ ಮಾಡ್ಬೇಕು ಅವಾಗ, move the mismatch character ಇಲ್ಲಿಂದ 7th ಪೊಸಿಷನ್ ಇಂದ ಎಂಟೈರ್ ಪ್ಯಾಟರ್ನ್ ಅನ್ನ ನೆಕ್ಸ್ಟ್ ಪೊಸಿಷನ್ ಗೆ ಮೂವ್ ಮಾಡಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಪೊಸಿಷನ್ ಆಫ್ ಮಿಸ್ಮ್ಯಾಚ್ ಯಾವುದು?
8.
8. So T will be moved to T and 8th position. A will be moved to 9th position like this. Can you notice down? ನೋಡಿ, ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ನೋಡಿ ಈಗ once again we will start comparison. G will be matched with G, T will be matched with T, G will be matched with G, T will be mapped with TA and T. So everything is matches, so search will stop over here. Okay, so here we have a mismatch at the position 7. The mismatching character, that is C, which is not at all present in the pattern illa. So what we have to do now, so in pattern, so in position 7, so we will shift. ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಎಂಟೈರ್ ಪ್ಯಾಟರ್ನ್ ಅನ್ನ ಶಿಫ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀವಿ. ಸೊ ವಿ ವಿಲ್ ಶಿಫ್ಟ್ ದ ಎಂಟೈರ್ ಪ್ಯಾಟರ್ನ್ past to the position 7. Past means after position 7. And eventually in the above example we have got a perfect match. But ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, ನಮ್ಮ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಮ್ಯಾಚ್ ಆಗ್ತಾ ಇದೆ. ಸಪೋಸ್ ಇಫ್ ಮಿಸ್ ಮ್ಯಾಚ್ ಅಕರ್ಸ್ ಅಂದ್ರೆ once again ಅದೇ ಪ್ರಾಸೆಸ್ ರಿಪೀಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, so that is why match occurs, that is displayed in green. Okay, so we are doing this because C do not exist in the pattern. ಯಾಕೆ ಅಂತಂದ್ರೆ ಎಲ್ಲೂ ಕೂಡ ಪ್ಯಾಟರ್ನ್ ನಲ್ಲಿ C ಇಲ್ಲ. Okay, so that every position shift before 7 we will get mismatch. Suppose ಇಲ್ಲೆಲ್ಲೋ C ಇತ್ತು ಅಂತ ಅನ್ಕೊಳ್ಳಿ, C ಇದ್ರೆ in case suppose C ಇತ್ತು ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ? Then we have to go here. ನೋಡಿ, mismatch becomes match. ಈ ಟೆಕ್ನಿಕ್ ನ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಮ್ಯಾಚ್ ಆದ್ರೆ ಈ ಟೆಕ್ನಿಕ್, ಮಿಸ್ ಮ್ಯಾಚ್ ಆಯ್ತು ಅಂತಂದ್ರೆ ಕೇಸ್ 2. Got it?
Yes, sir. Got it.
Yes, dear students, understood?
Understood,
Okay,
sir.
ನೋಡಿ, that is why we have to create two tables. One table for mismatch becomes match and another table for pattern move past the mismatch. So this is all about the Boyer's-Moore algorithm. So you may be getting a question, discuss input enhancement using Boyer-Moore algorithm with suitable examples. We can explain these things. And I have already uploaded this PPT and as well as yesterday's PPT in the Google Classroom. And also I am going to do upload this in the group, WhatsApp group also. At the home, just go through once. Okay, then with all this I am going to stop today. Okay. So if you have any queries, you can ask me. Tomorrow or in the next class, we may have to continue with hashing. Hashing is the next technique what we have to discuss. Okay, then I request all of you to give the attendance to the chat box. Okay, fine. If everything is over, shall we quit? Shall we stop?